Hello all. So in the last session we have started with few of the combinational logic circuits. Today we'll continue the same. We will deal with two more important combinational logic circuits which are called as multiplexers and demultiplexers. So let's begin the session today with multiplexer. So when we talk about multiplexers are the combinational logic circuits which can take the data and give the data in a single output line, which can take 2 power n input lines and give you the data in a single output line. Okay, so as you can see, we will take 2 to the power of n data inputs and produce one single output, and this will be based on n selection lines. So in short, for 2 to the power of n inputs, we will have n selection lines and one output line. Okay, so one of these data inputs that we are giving will be produced at the output depending upon the selection lines. So here we will be varying our selection lines depending upon what combination of selection lines we take. One of the input will be produced at the output. Okay, so when we take n selections line, we will have 2 to the power of n possible combinations of zeros and ones. Okay, so for each combination, one of the data input will be selected and that will be produced at the output. So this particular functionality is implemented by multiplexer, which we call as MUX in short. Okay, so based upon how many selection lines we take, we will have 4 different types of multiplexers. Even we can extend it more. For our syllabus, we will be discussing about 4 different multiplexers. So one is called as 2 by 1 multiplexer. When you have one selection line, we will have 2 to the power of 1 input lines and 1 output line. Hence we call it as 2 by 1 multiplexer. When we take 2 selection lines, we will have 2 power 2 inputs, that is 4 input 1 output. So we call it as 4 by 1 mux. When we have 3 select lines, 2 to the power of 3 inputs, that is 8 inputs and 1 output, which is called as 8 by 1 mux. When we take 4 select lines, we have 2 power 4 inputs, that is 16 inputs and 1 output, which we call it as 16 by 1 multiplexer. So when you can see this particular classification here, depending upon the selection lines, we are varying our inputs, but output is only one for all different types of multiplexers. Okay, now let's get into the first classification of multiplexer, which is 2 by 1 multiplexer. Okay, so 2 by 1 multiplexer is a combinational logic circuits that has only 2 inputs. Okay, so here let us consider look at the block diagram here. So we will consider the 2 inputs as A0 and A1, and for these 2 inputs we have only one select input, and along with that we have output. In the last sessions, as discussed, we will add enable input as a switch. Okay, so when your enable input is activated, only the other inputs will work and the output will respond to those inputs. Okay, now on the basis of the combination of these inputs that are present at the selection line S0, one of these 2 inputs will be produced at the output line. Okay, now look into this particular truth table. I have this select inputs. I am not considering my inputs here. Okay, now I have my select input here. If select input is 0, the first input A0 is produced at the output. If the select input is 1, A1 is produced at the output. So as I told you, depending upon the combination of select inputs, one of the input will be appearing at the output. Okay, so as I have only one select input here, if it is 0, A0 input will appear at the output. If select input is 1, A1 will appear at the output. So that is the block diagram, and this is the truth table for 2 by 1 multiplexer. Okay, now let's look into 4 by 1 multiplexer. So when I talk about 4 by 1 multiplexer, I'll have 2 selection inputs because 2 power 2 is 4 inputs. Okay, that is the reason we call it as 4 by 1 multiplexer. Okay, now 4 by 1 multiplexer has 4 inputs, which I have labeled as I0, I1, I2, I3. It will have 2 select inputs S0, S1, and it will have one output, which is Y. Okay, now this is the truth table. So when I look into the truth table, I'll mention my select inputs. So how many select inputs did I take? I've taken 2 select inputs, S0 and S1. So for S0 and S1, I'll have 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so when select inputs are 0, 0, I0, that is the first input will appear at the output if it is 0, 0. If select input is 0, 1, I1 will appear at the output. If select input is 1, 0, I2 will appear at the output. If select input is 1, 1, I3 will appear at the output. So just remind that We are not taking the inputs here in the truth table. We are taking the select line combinations of inputs. Based on that, one of the input will appear at the output. Okay. Now from this particular truth table, I'll directly write the function for y. Okay. So how is my y written? Y is nothing but I naught into S naught bar S1 bar. Okay. Plus I1 into S naught S1 bar plus I2 into S naught bar S1 plus I3 into S naught and S1. So this is the Boolean function that I have written for 4 by 1 multiplexer. So for this Boolean function, we will draw the logic circuit. This is the combinational logic circuit for 4 by 1 multiplexer. So as you can see, here I am taking S0 and S1 combinations. Along with that, I am adding these 3 inputs. So based on what combination of S0 and S1 you take, that particular input will be produced at your output end. Okay. So this is the combinational logic circuit for 4 by 1 multiplexer. Okay. Now let's go for implementing higher order multiplexer. When I talk about higher order multiplexer, higher inputs comes into picture. So we have seen 2 by 1 multiplexer, 4 by 1 multiplexer. Now using them, we will construct 8 by 1 multiplexer and 16 by 1 multiplexer. Okay. So higher order multiplexers using the we will not design 8 by 1 or 16 by 1 from scratch, that is by using AND and OR gates, but instead we will use the lower order multiplexer for designing for 8 by 1 and 16 by 1. Okay. Now first let's look into 8 by 1. So when I talk about 8 by 1, how many select inputs do we have? 3. For 3 select inputs, we will have 2 power 3, that is 8 input combinations and 1 output, right? So for designing 8 by 1 multiplexer, we will be making use of 4 by 1 multiplexers and 2 by 1 multiplexers. Okay. Now how do we do that? Look at this diagram before we go into that. Yes, when you look into this, I am making use of 2 4 by 1 multiplexers wherein I will accommodate 8 inputs. So, I0 to I3 to the lower multiplexer, I4 to I7 to the higher multiplexer, and I am taking S0 and S1 as common. Okay, S0 and S1 for common for both the multiplexers, and as I have only one output produced for each of the multiplexers, I am giving them to 2 by 1 multiplexer wherein I am applying the third select lines. See, when I go for 8 by 1 multiplexer, I'll have 3 select inputs, right? S0, S1 and S2. So S0, S1 I am taking it common to these, because for 4 by 1 I can take only 2 select inputs, and the third select input I am applying it to 2 by 1 multiplexer. So the 2 by 1 multiplexer will have the inputs coming from 4 by 1. Along with that, it will also have the third select input, which is S2, and then I will have my output Y. Okay. Now, we already know that, we've already seen that 4 by 1 multiplexers has 4 inputs, 2 selections lines and 1 output, right? So, for designing 8 by 1 multiplexers, we require 8 inputs, 3 select lines and 1 input. So, here we are taking 2 4 by 1 multiplexers in the first stage in order to accommodate those 8 data inputs, and each 4 by 1 multiplexer will produce one output which we are connecting it to a 2 by 1 multiplexer in the second stage. Okay. Now this would be the truth table as seen earlier. S0, S1, S2 will produce 8 different combinations of zeros and ones, for which one of the input will be represented at the output end. Okay. So this is the diagram for implementation diagram for 8 by 1 multiplexer using 4 by 1 and 2 by 1 multiplexers. Okay. Now as you can see here, the same selection lines S0 and S1 are applied to the first stage, that is the lower and upper 4 by 1 multiplexers. Okay. The lower one will have inputs from I0 to I3, and the higher multiplexer will have inputs from I4 to I7, whereas each 4 by 1 multiplexer produces one output which are again connected to the 2 by 1 multiplexer. Okay. Now when you look into this particular figure, the output is totally dependent on this S2 here. Okay. S2, which is the select line for 2 by 1 multiplexer. Okay. Now if S2 is 0, okay, then the output of 2 by 1 multiplexer will be one of the 4 inputs from I3 to I0. So when it is 0, this will come activated and one of the inputs will appear at the output. Okay. When S2 is 1, this will be activated and one of the inputs from I4 to I7 will appear at the output. Okay. So this is all about your 8 by 1 multiplexer using 4 by 1 multiplexers and 2 by 1 multiplexers. Okay, next we'll switch on to 16 by 1 multiplexer. Okay, now to implement 16 by 1 multiplexer, we will be making use of two 8 by 1 multiplexers. Okay, apart from that, we will also make use of 2 by 1 multiplexer. Okay, now for designing 16 by 1 multiplexer, as you can see, we will have 4 select inputs S0, S1, S2, S3. For 4 select inputs, we will have 16 combinations 0 to 15, and depending upon these 16 combination, one of the inputs from I0 to I15 will appear at the output. Okay. Now when you look into this particular block diagram, okay, so we have two 8 by 1 multiplexer. One 8 by 1 multiplexer will take inputs from I0 to I7, and the second upper 8 by 1 multiplexer will take the inputs from I8 to I15. So here for 16 by 1 multiplexer, I have 4 select inputs, right? So for those 4 select inputs, 3 select inputs I will be taking into common for both of this, termed as S0, S1 and S2. And when you come for the outputs, I have 2 outputs, hence I am taking 2 by 1 multiplexer, and the third, fourth select inputs S3, I am giving it as input to this 2 by 1 multiplexer. Okay. Now if S3 is 0, one of them will be selected, I0 to I7 will be selected, and that will appear at the output. When S3 is 1, depending upon S0, S1 and S2 of upper 8 by 1, one of the inputs, that is I8 to I15, will appear at the output. Let us take an example. If suppose I have this combination 0, 111, okay, S3 is 0, S0, S1, S2 are 111, okay. When S3 is 0, this particular multiplier will be activated. When it is 111, when S0, S1, S2 are 111, I7. Hence, for 0, 111, I7 will appear at the output. Okay. So this is the logic diagram for implementing 16 by 1 multiplexer using 8 by 1 multiplexer and 2 by 1 multiplexer. Okay. The same thing. Okay. Same selection lines S0, S1, S2 are applied to both multiplexer. That is, the lower 8 by 1 multiplexer will have I0 to I7. The upper multiplexer will have I8 to I15, and the 3 select inputs are given as common. The output of both these 8 by 1 multiplexers are given to 2 by 1 multiplexer as input, along with S3 select input, which produces the final output, which is Y. Okay. So this is all about your multiplexers. Okay. And the next combinational logic circuit, which is opposite to multiplexer, is demultiplexer. Okay. So demultiplexer is a combinational logic circuit that performs reverse operation of multiplexer. Okay. So here the input and outputs are exchanged, but the select input would be same. Okay. So for n select inputs, we will have one input and 2 power n output combinations. Okay. So depending upon the select inputs, the input that we give will appear at one of the output combinations. Okay. So there are n selection lines. There will be 2 power n possible combinations of zeros and ones, and for each combination, the input will appear only at one output. Okay. So demultiplexer, in short, we also refer to that as demux. Okay. So first let's directly go to 1 by 4 demux. Okay. So as you can see here in the diagram, I is the only input that I am giving. Depending upon the select inputs S0 and S1, this particular input I will either appear at Y3 or Y2 or Y1 or Y0. If it is 0, 0, I will appear at Y0. If it is 0, 1, I will appear at Y1. If it is 1, 0, I will appear at Y2. If it is 1, 1, I will appear at Y3. Okay. So depending upon select lines, the only input that we have will appear at one of the output combinations for demultiplexer. Okay. So this is the block diagram for 1 by 4 demultiplexer, and this would be the truth table. Okay. Now as you can see, I have two select inputs 0, 0, 0, 1, 1, 0 and 1, 1. Now as you can see, for 0, 0, my I is appearing at Y0. For 0, 1, I is appearing at Y1. For 1, 0, I will appear at Y2. For 1, 1 combination, I will appear at Y3. Here the truth table would be different, bit different compared to multiplexer. Let's look at this. So what is Y3? Y3 is nothing but I with S0 and S1. So we have 4 outputs here. In case of multiplexer, we had only one output. Here we have 4 outputs for demultiplexer. So Y3 output is all about I into S0 S1. Y2 is all about I into S0 bar S1. Y1 is all about I into S node S1 bar, and Y node is all about I into S node and S node bar and S1 bar. Okay, so this is the truth table, and these are the Boolean functions for 4 outputs of 1/4 demultiplexer. Okay, using those Boolean functions, I have designed my logic diagram here. Okay, so only one input, this one input along with these 2 select inputs which are applied to the logic diagram will produce 4 outputs, which are Y0, Y1, Y2 and Y3. Okay, now similar to 1/4 demultiplexer, we will try to design the higher end multiplexers, 1/8 demultiplexer and 1/16 demultiplexer using 1/4. Okay, now let's get to 1/8 demultiplexer. Okay, now how do we design 1/8 demultiplexer? We will design 1/8 demultiplexer using 2 1/4 and 1/2 demultiplexer, like what we have seen for multiplexers. Okay, now this would be the truth table. When I talk about 1/8, I have 8 outputs for which I need 3 select inputs. So the 3 select inputs are S0, S1, S2. For 3 select inputs, I have 8 different combinations starting from 0, 0, 0 to 1, 1, 1. Okay, now when it is 0, 0, 0, the input I that I have, the only input that I have will appear at Y0. When it is 0, 0, 1, I will appear at Y1. When it is 0, 1, 0, I will appear at 1, 2. Similarly, when it is 1, 1, 1, I will appear at Y7. For this particular truth table, I will derive the logic functions, and based on the logic functions, I have it here. So here I have one input, right? So that one input will be given to 1/2, which will produce 2 outputs, where I am taking 1 select inputs out of 3, and the outputs of these 1/2 are given as input to the upper and lower 1/4 demultiplexer, for which I am giving 2 other select inputs as common, and which will produce the outputs Y0 to Y7. Okay, exactly the reverse functionality of multiplexer will happen in demultiplexers. Okay, so this is the logic diagram for 1/8 demultiplexer. Okay, so the common select lines S0 and S1 are given to both 1/4 demultiplexers, the upper and lower. The lower will have outputs producing Y0 to Y4, as you can see, the lower producing outputs Y0 to Y3, and the upper will produce Y4 to Y7. Okay, the select lines S0, S1 are commonly given to the lower and upper demultiplexer, and S2 is given to 1/2 demultiplexer. So this is all about 1/8 demultiplexer. Okay, so the last circuit that we are going to discuss today is all about 1/16 demultiplexer. Okay, as we have seen in multiplexer, 1/16 is designed using 2 1/8 demultiplexer and 1/2 demultiplexer. Okay, let's look into the diagram first. Yes. Okay, so first I'll take 1/2 demultiplexer, for which I have one input I that I am giving along with the select input S3, and the outputs of this are given as inputs to the lower and the upper 1/8 demultiplexer, which will produce 16 outputs. The lower one produces Y0 to Y7, and the upper one will produce the outputs Y8 to Y15. Okay, so S3 is given to 1/2 demultiplexer. If S3 is 0, this will be activated. If S3 is 1, this will be activated. Depending upon S3, S0, S1, S2, this I input will appear either at Y0 to Y7 or Y8 to Y15. Okay, so this is all about 1/16 demultiplexer. Okay, so today in the class we have discussed about what are multiplexers, 2/1, 4/1, 8/1 and 16/1 multiplexers. Along with that, we have seen the reverse functionality of multiplexers, which are demultiplexers. We have seen 1/4 demultiplexer, 1/8 demultiplexer and 1/16 demultiplexers. Okay, now let's quickly recap or understand the basic differences between multiplexers and demultiplexers. Okay, so when we look into the definition, multiplexer is a combinational logic circuit that takes multiple data inputs and produces one digital output. Okay, whereas when you talk about demultiplexer, it is a combinational logic circuit that takes single input and produces multiple outputs. Okay, so multiplexer we shortly call it as mux, and demultiplexer we call it as demux. Okay, when you talk about input and output, we have 2 power n input lines, n select lines, 1 output line for multiplexer, whereas when we talk about demultiplexer, we will have 2 power n output lines, n select lines, and 1 input line. Okay, so multiplexer is basically called as data selector. Okay, so out of n inputs, I am connecting it to one of the outputs, so we call it as data selector. When you talk about demultiplexer, this one input is distributed among many outputs, so we call it as data distributor. Please make a note of it. Okay, now operating principle, multiplexer will have many inputs, one output, so we call it as many to one principle, whereas for demultiplexer we have one input, many outputs, hence we call it as many to one to many. Okay, now when we talk about multiplexer, it acts as digital multi-position switch. We have many inputs and one, so we call it as multi-position switch, whereas demultiplexer simply acts as one digital circuit. Okay, so multiplexer performs parallel to serial, many to one, right? So we call it as parallel to serial conversion, whereas demultiplexer we will use it for serial to parallel conversion. Okay, when you talk about function of control signal, the function of control signal is to select specific input that has to be transmitted to the outputs in multiplexer, whereas in demultiplexer the functionality is to deliver one particular input to the specific multiple output lines. Okay, now when you talk about examples or different types of multiplexers, we have 8 by 1, 16 by 1, 32 by 1, and so on, depending upon how many select lines we take. Similarly, we have 1 by 2, 1 by 4, 1 by 8, 1 by 16 demultiplexers. Okay, when we talk about practical applications of multiplexers, multiplexers will increase the efficiency of communication. Basically, we use multiplexers and demultiplexers for data transmission. Okay, so when you talk about that, the efficiency of the communication system will be improved when you are going for data transmission here. Similarly, when you talk about demultiplexer, it takes the output of the multiplexer and converts it to the original from the receiver end. Okay, so when you go for practical applications in time division, multiplexing and all that, we'll be using both multiplexers and demultiplexers. Okay, so when you talk about applications, we use them in computer memories, communication systems, telephone networks, and so on, the multiplexers. When you go for demultiplexers, we use them in reconstruction of data, we use them in communication systems, we use them mathematical and logical unit, etc. Okay, so these are various differences in applications of multiplexers and demultiplexers. Okay, thank you so much.